Bismillahirrahmanirrahim. This time we're going to be dealing with workbook questions related to chapter number 9. Okay, this is on page number 60 and 61 basically. Yeah, we have basic questions. Question number 1 is simple conversion of units, which will be your homework. This is something you should practice by yourself. Question number 2 is also very simple, so you're supposed to do this as a homework. Question number 4 and 5 also will be your homework. Question number 3, we're going to skip it, so don't do question number 3. We're going to be doing question number 6 right now in the lectures, okay? Starting from question number 6. First of all, read the question. What does it says? Let me just bring it down a little bit. Okay. First of all, we have the question which says, a cuboid has a length is given to us, the breadth is given to us, and the height is given to us. Length, breadth, height of a cuboid is given to us, okay? So we can find the total volume of the cuboid. It says we need to find the number of cubes, each having the length of 20 centimeters, which can be cut from the cuboid. Basically, we have a big cuboid, right, which has a total volume of something, and we're going to be cutting pieces of small cubes from it, just like we did in question number 5 of exercise 9a, if you remember this question, in which the big volume was given to us and we melted the cuboid into smaller cubes, right? So we melted it and made small cubes. Here we're just simply cutting it into small cubes instead of melting it, but the basic thing is the same pattern here as well. So we're going to find the total volume, and then we're going to divide it by the volume of each small cube, and then we will know the number of cubes that we need to find. This is really important, this formula that we're going to discuss in this chapter, okay, this question basically. Yeah, okay, first of all, start with knowing that this is a cuboid. Length is equal to 4.2 meters, breadth is equal to 1.4 meters, and height is equal to 1.2 meters. I simply did what? One more thing that you need to understand in this question is that the dimensions of the cuboid is given in meters, while the dimension of the cube is given in centimeters. So there's a difference. We need to get rid of this difference. We need to make sure that we're using the same unit. Either we're using the meters or we're going to use centimeters. I chose to use centimeters because if I was to use meters, then I would have to deal with points, and I don't want to deal with decimals. So I'm going to use centimeters. I'm going to convert each length that's given to me in meters in centimeters, okay? So if 1 meter is equal to 100 centimeters, 4.2 meters is going to be 420 centimeters, and 1.4 meters is going to be 140 centimeters. Similarly, 1.2 meters is going to be 120 centimeters. I converted all of them into centimeters. Now the decimals are being converted into proper whole numbers, right? So it's easier for me to multiply them and deal with them. So length multiplied by breadth multiplied by height, I can just simply multiply them as decimals, or I can just convert them into centimeters and multiply the whole numbers, which is easier for me. I get 7,056,000 as my cubic centimeter as my total volume. This is the total volume of what? Cuboid, okay? This volume of cuboid is being cut into smaller cubes, okay? You take the cuboid, you're going to cut it into smaller cubes. For example, we have this Rubik's cube, right? I'm going to cut it into smaller cubes of this size, right? So how many cubes will I have? 1, 2, 3, 4, 5. I'm going to count all of them, and there will be about, well, basically 3 multiplied by 3 multiplied by 3, right? So 3 3s are 9, and 9 3s are 27. So basically I will have 27 smaller cubes just from this one Rubik's cube, okay? So the one Rubik's cube is being cut into 27 smaller cubes here. I can do the similar, basically the same thing is happening here with the cuboid. The cuboid is going to be cut into smaller cubes, okay? We found the total volume of the cuboid. Now we're going to find the volume of the smaller cube. We know the length, which is 20, and that's all that we need to know for a cube, right? So the volume of the smaller cube is length multiplied by length multiplied by length. Length is 20, so 20 multiplied by 20 multiplied by 20, and this will give us 8,000 cubic centimeter as the volume of the smaller cubes. Each smaller cube will have this as its volume, right? So the number of cubes that can be obtained from the cuboid by cutting it is going to be total volume of the cuboid divided by volume of each cube, right? Volume of each cube. So the total volume, we already know that's 7,056,000. So we're going to divide it by 8,000, right? And we will get, cancel out the zeros. You just have to divide 7,056 by 8. You'll get 882. This is the number of cubes that can be cut from the cuboid, okay? Again, we've done something similar before, and we've used this formula again and again, over and over, not only in this chapter, but in the chapters of linear equation as well. The number of dash or number of this or number of that, doesn't matter what it is, but the number of this and the total and divided by each. That's what it is, okay? So number is equal to total divided by each. This is really important. We use this formula again and again, so you should make sure you remember this, okay? Like for example, if you remember that we did I just explained it recently, but let's just try this one more time. I have, for example, I have 1,000 rupees. That's my total money, right? And each apple, let's just say, each apple costs 50 rupees. Each apple will cost 50 rupees. How many apples can I buy? So again, the number is question mark. Number will be equal to what? Number will be equal to total divided by cost of each. Okay, yeah, so we're saying number is equal to total divided by each. Number of apples that I can buy is going to be equal to total, which is 1000 divided by the price of each is going to be 50, right? So 1000 divided by 50, basically 100 divided by 5, and you're going to get 20 as the number of apples that I can buy, right? I just wanted to show that this is important. Number is equal to total divided by each. We have used this many times, you just need to remember this, okay? Question number 6, that's it about question number 6. It was pretty easy. After question number 6, we have question number 7. Question number 7. We again have the trough. A trough question we have here, huh? Trough is tough. Trough is in the form of an open rectangular box. Now this is the important statement. It's an open rectangular box. We know what an open rectangular box is. It's a cuboid, right? A cuboid is 8 meters long. Okay, we know how long it is. It is 3 meters wide, so we know the breadth and we know the height as well. It initially contained this much water. Okay, so rectangular box, length is this, breadth is this, height is this, initially contained this much water. All this is the information that is given to me in the question, so I just wrote it down. Then it says that, yeah, find the depth of water. Basically they're asking us to find the height in the tub after 20 cubic meter of water is added. Okay, so initially we had 37 cubic meters, and now after adding 20, basically 37 plus 20, it's 57 cubic meters. This is the new volume of water, right? So after adding 20 cubic meters, what is going to be the new height of water, basically, right? So this question, we've done similar questions before in the exercise, and I feel like this is it's good for us to understand it better, so I'm going to show you in a better way. Practically explain this a bit. Nope. Okay, take a look at this. It's a kind of glass, but the thing is that it's kind of a cuboidal shape, right? So it has a length and it has a breadth. If you take a look, it has a length. Let's just say this is the length and this side will be the breadth. Okay, this is the height. This is the height. I'm gonna fill it with water a little bit. See, let me just pour some water in it. Okay, let's say this much water. Take a look at it now. Take a look at the water. Water has the same length as that of the glass, right? As that of the cuboidal shape. It has the same length as that. And then it has the same breadth as well. And the height is different. The height of the glass is all the way up here, while the height of water is only till here, right? The height of water is still here. Remember this. The height of water is much less than the glass. Now what I'm going to do, I'm going to add some more water in it. Let's just say the water that I'm adding is about 20 liters, just like in the question, right? What changed? Did the length change? No, the length remained the same. Did the breadth change? No, the breadth is also the same. What changed? The height. It was still here before and now it's here. The height changed, okay? The height maybe is still less than the original length of the cuboidal shape. The height of water is still less than the height of the cuboidal shape, but it is still more than what it was before, right? So what changed? When I increase the amount of water, the height is going to increase. When I decrease the amount of water, the height of water is going to decrease. The length and breadth are going to remain the same. And that's what's important in this question and what some other questions that we've done before. One more thing about this cuboidal shape that you need to understand is, look at the water. Water is in contact with this surface here. It's in contact here. It's in contact on the back and here as well. And it's on the contact with the bottom. So it's contact here, 1, 2, 3, 4, and 5. So on 5 faces or surfaces of the cuboidal shape, the water is in contact with. Water is not in contact with the top, okay? Top is open. There's no face on the open. It's an open end. There's no contact here, right? So only 5 surfaces it's in contact with. One more thing is that it's covering the complete area on the bottom. It's covering the complete area on the bottom. It's completely in contact with the bottom face, but it is not completely in contact with the it is not completely in contact with, let me just show you from it is not completely in contact with the faces on the front, back, right and left. Okay, water is in contact with the surface of this cuboid only till here. After this there is no contact between the water and the surface of cuboid. Okay, only till here. So if I was to calculate the entire surface of the water, if I was to say that the water is in contact with this entire face, I would be wrong. Okay, so what we need to do is we need to take this as our height then. Okay, this is going to be our height when we're calculating how much the water is in contact with the surface. Okay, I'm going to explain it again when we're doing the question. For now, just keep this in mind. Okay, going back to question number 7. Yeah. We know the new volume of the water after we added added 20 cubic meters of water was 57, right? 57 cubic meters is the new volume of water. So we want to find the height, the new height. Okay, height is going to change after we're going to add water, right? So the new height of the water is going to be volume multiplied by length multiplied by breadth. Length and breadth are going to remain the same. It's 8 multiplied by 3, and h, we want to find h. We know the new volume is 57, so we're going to place it here. And again, I don't need to mention the units because they're all the same. They're all in meters or meter cube, right? So 57 is equal to 24 h, right? So we're going to divide 24 on both sides. You'll get the value of h, which is going to be equal to 2.375 meters. You don't have to be that perfect in the division. You just can go like 2.37 or just this. That's enough meters. Okay, so the height is going to be this much meters. That's basically it in this question number 7. Then we're going to discuss question number 8. Question number 8 says, each dormitory comes in the form of a cuboid of dimensions 12 meters long, 7 meters wide, and 3 meters high. Each student must have 14 meters cubic meter of air when he is in the dormitory. Find the volume of air contained in each dormitory, the number of students allowed to stay in each dormitory. Basically, first of all, we have dormitory, right? And its dimensions are given to us. The length is given, breadth is given, and height is given. So we can find the total volume of each of the dormitories, right? So we're going to start with that. We're going to start with finding the volume of each dormitory. Now, obviously, the dormitory isn't in space, so every corner and everything, every space inside the dormitory is just filled with air, right? So the total volume of the dormitory is going to be the total volume of air. Now, practically speaking, it is true that dormitory just doesn't only have air. A dormitory will have furniture in it, it will have beds in it, it may have table in it, and many other things like chairs or doors and a lot of other things, right? A dormitory will have all of those things, and they will also have some volume, right? So me saying that the total volume of the dormitory is going to be the total volume of air is practically wrong. Yeah, but right now we're mathematicians, not scientists. Okay, so we're not going to worry about anything like that much. Okay, it's okay. We don't have other information of whatever is inside the dormitory, right? We don't know what is inside the dormitory, whether it's empty, whether it has a lot of stuff in it, how much of the air is displaced with things, and how much of the total volume of air. We cannot practically tell the actual volume of air inside the dormitory. So we're just going to assume for now, theoretically, saying that the total volume of each dormitory is going to be equal to the total volume of air. Realistically, that is not true, but for us, it doesn't really matter, okay? Yeah, so one more thing you need to remember is that when we're saying that total volume of each dormitory is equal to total volume of air, that's wrong in real life, but right now it doesn't matter. It's easier to solve the question this way, so we're going to take it like that, okay? One more thing, the volume that we're going to find, the total volume of each dormitory, in reality, the total volume of air is always going to be less than what the total volume of each dormitory is. So if this is the total volume of each dormitory, the total volume of air is going to be something less than that, okay? But right now it doesn't matter, so we're just going to assume that this total volume is the total volume of air, okay? Length is given, breadth is given, height is given. Once we find the total volume of each dormitory, we're going to say that that's the total volume of air because the dormitory is filled with air. Okay, each student needs about 14 cubic meters of air, and the total given to us is 253 cubic meters. This is again pretty much very similar to question number, which question was it? Yeah, question number 6 we did, right? So the number of students is going to be equal to the total volume of air divided by air for each student, right? So total volume of air is 252 and volume for each is 14. So 252 divided by 14 is going to be 18. So the number of students that are allowed to be in the dorm is 18. Okay, again very similar to question number 6. It's not really that hard, but there was only part 1. That was only part 1 of question number 8. Question number 8 part 2 says the number of, oh yeah, that was part 2 as well. Oh, okay, fine, we're done with this question. It was pretty easy. Question number 9, skip this one. Okay, it is unnecessarily long and confusing, so we're going to skip question number 9. We're going to skip question number 10 part B as well. Okay, so we're skipping three things here. We're skipping question number 3, skipping question number 9, and question number 10 part B, only part B. Part B is basically involves cylindrical shapes, and we have not done cylinders. We have done cubes and cuboids in this chapter, so this is completely wrong. We don't have the necessary concept yet for to be able to solve these questions, right? So we're going to do question number 10 part A now. Question number 10 part A. What does the question says? Question says we have an open rectangular tank of length 40 centimeter, breadth 28 centimeter, and height 18 centimeter. Again, we have the necessary knowledge. We have length, we have breadth, we have height. We can find the total volume of the open rectangular tank. They say that it was initially empty and now Ali poured 12 liter of water in the tank. Find the height of water in the tank, right? Initially, just like the cup was empty, the tank was also empty, and I poured some water in it. So how much water did Ali pour? 12 liters of water, right? So we're going to see how much the water is now, how much height does the water have in the tank, rectangular tank, right? So for that, what are we going to do? We're going to start with finding, we're going to start with just the basics. Again, in the question, it says that it has a rectangular tank, right? So rectangular tank is what? A cuboid. Cuboid has length, breadth, and height given to us. Ali had 12 liters of water. First, we're going to find the basically in this question, the height that is given to us is the height of the rectangular tank, and it is really not important to us right now because in the question we have to find the height, right? In question number 10, question part A, the first part that we have to do is to find the height of the water, right? So this height is basically useless. It doesn't really matter. What are we going to do? We're going to first find the volume in cubic centimeters. Why? Because the data given to me, the length given to me, the breadth given to me, the height given to me, all of them are in centimeters, while the water that he added is in liters. So we're going to convert liters into cubic centimeter, right? So how we're going to do that? Multiply 1,000. 12 multiplied 1,000 is 12,000. That's the volume of water that Ali added. Okay, so volume is going to be equal to 12 liter. We're going to convert the 12 liters into cubic centimeters. So 12,000 is going to be equal to length multiplied by breadth multiplied by height. We don't know what the height of water is, so we're going to leave h as it is. Multiply length with breadth, and then you get this. You're going to divide it on both sides. You'll get the value of h. H is going to be equal to 10.7, basically 10.7 centimeter. 10.7 centimeter. That's going to be the height. Now this was the easy part. Here we have the surface area of the tank that is in contact with the water. Give your answers in meter square. Okay, so the calculation that we're doing in the start, for example, okay, first of all, it's a cuboid. Yes, it's a cuboid with length 40, breadth 28 centimeter, and height 18 centimeter, right? But this height 18 is the height of the tank, not the height of water. The height of water is this. So the water is only touching the tank till this height. After this height, the water is not in contact with the tank. There is no contact between the water and tank. At 11 centimeter, at 12 centimeter, at 18 centimeter, there is no contact of water and the tank. So we're going to use this height in the formula of total surface area that is in contact, right? So again, when we're talking about the total surface area and the formula that we use in this chapter, that formula is for 6 faces. Cuboid has 6 faces, but since we're talking about open rectangular tank, that means one of the face is missing. We only have 5 faces here. So what are we going to do? We're going to subtract the top face. The top face is equal to length multiplied by breadth. So area of the top face, we're going to subtract it. Just put the values in, then 2 multiplied by length multiplied by breadth, it stays the same. Length multiplied by breadth, that was given in the question. We're just going to put the values here. The height that we have here it's going to be the height that we found in the previous part of this question, right? The height was 10.7 centimeter, right? So this height is going to be 10.7. Now basically we have long multiplication and addition here. Let's do this multiplication and addition and proceed with this question. You will get the value of the total surface area that is in contact with the total surface area of the tank that is in contact with water, right? But the answer that we got was in cubic centimeters, because the length was in centimeters, the height was in centimeters, the height was in centimeters, the breadth was in centimeters, height was length, all of them was in centimeters, right? So the answer that we got was also in cubic centimeters. What are we going to do? We're going to have to, wait a second, we're going to have to divide it by a million. The answer that we got, we're going to divide it by a million for us to convert the cubic centimeters into cubic meters, right? So 1 2 3 4 5 6, we're going to do 6 jumps, and this is the answer that we get, which is ridiculously small, apparently, okay. This is quite big when you see it physically though. Anyways, we have then 11 number question. Skip to part B of question number 10. We're going to do question number 11. Question number 11 says the total surface area of a solid cube is 294 centimeter square, right? That's total surface area of a cube is given. We know cube. Okay, so first of all, it is cube. We know the total surface area. We don't know the volume, and we don't know the length as well. In case of a cube, the total surface area is equal to 6 multiplied by length square, right? This is the formula for total surface area of a cube. We know the value of total surface area, so we're going to replace it with its value, which is 294, which is equal to 6L square. Now we're going to divide 6 on both sides. We're going to get 49. 49 is basically equal to L square. And what is L square? L square is length multiplied by length. Which number multiplied by itself will give you 49? 7. 7 multiplied by 7 is 49. That's why length is going to be 7 centimeters. Once we know the length, that's enough, because volume is equal to length multiplied by length multiplied by length. So multiply 7 multiply 7 multiply 7, you will get 343. That's going to be cubic centimeters, right? Because it was 7 centimeter. So cubic centimeters, this is our volume of this solid cube. Volume of this solid cube. In question number 11 part 2, it's not difficult, it looks difficult. All that you need to know is basically this thing: density is equal to mass divided by volume. Density is a variable, mass is a variable, and volume is a variable, just like we did speed. Speed is equal to distance divided by time, right? So density is equal to mass divided by volume. You just need to remember that. That's it, okay? Mass is given to us in the question, right? Mass is given to us in the question. Volume, we just found the volume, okay? But the problem is the volume is in cubic centimeters, right? The question is telling us to find the density in kilograms, which is mass, per cubic meters. Cubic meter is the unit of volume, right? But we have cubic centimeters. We need to convert the cubic centimeters into cubic meters. So what do we need to do? We're going to have to divide it by a million. You divide it by a million, you will get this value, 0.000343. So divide 1.47 divided by 0.000343. You can just use a calculator, but if you want to do it properly by yourself, then you would have to, in my opinion, first get rid of the decimal points. To get rid of all the decimal points, you will have to multiply million on the top and multiply million on the bottom. You will guess this digit, and then you will have to divide the top with the bottom, and you will get basically 4,285 kilograms per cubic meter. That is basically the density of what we need to find. Is this the water that we're talking about? Like, I don't know whatever this thing is, but yeah, that's the density. Anyways, that's the density of the cube, right? Basically, just a simple thing is that density is equal to mass divided by volume. If mass and volume is given, then you can find the density. If density and volume is given, then you can find the mass. If mass and density is given, then you can find the volume. It's pretty just simple. You just need to change their position like we do in linear equations. Question number 12. An open tank. Again, we have an open rectangular tank. So it's a cuboidal shape without one face, without a top face, which is only 5 faces in it. Okay, let's just say it is 1.1 meters long 60 centimeters wide. Okay, focus here. The length is given in meters, breadth is given in centimeters, height is given in centimeters. So what are we going to do? We're going to convert the length that is given to us in centimeters. The length is given in meters, we're going to convert it into centimeters. 1.1 meter is going to be 110 centimeters, right? For now, focus on the question. Initially, 5 by 8 of this volume is filled with liquid. This is given in the question. How many extra liters of liquid are needed to fill up the tank? Basically, it's asking us about the empty space. How much is the empty space in the tank? This much is filled, so how much is the empty space that can be filled by adding more liquid, right? So that's what it's asking. And first let's find out and then we'll discuss part 2. Okay, so it's a cuboidal tank. Length is given, breadth is given, height is given. I'm just going to convert the length into length from meter into centimeter, so that I told you length, breadth and height needs to be in the same unit, right? So they have to be in the same unit. That's why I converted the meters into centimeters. Okay, just simply multiply them. You will get the total volume of the cuboid tank in cubic centimeters, right? Then what we need to do, basically the first part of this question is asking us, is saying that 5 by 8 of this is filled, so 3 by 8 is going to be empty. How do I know this? Just if some of you are confused, let me just explain it practically a bit. Okay, take a look at this. It is a square which has 4 small parts. 1, 2, 3, 4. 4 equal parts. This square is being cut into 4 equal parts, right? I say that, let's just say this means filled. I'm saying 3 by 4 parts are filled. That means 1 by 4 part is empty, right? This is basically what it means. If it has a total of how many parts? 4 parts, and 3 of them are filled, then 1 of them is going to be empty, right? Similarly, here we have a total of 8 parts. If 8 of them is filled, if out of total 8 parts, 5 of them are filled, then how many are left? 3 parts, yeah. So 3 of them are going to be empty. 5 of them are filled, 3 of them are empty. 5 plus 3, total, we get the total back, which is 8, right? So 8 of them is going to be empty, and that is the volume that needs to be filled, right? So the empty volume that needs to be filled is 3 by 8 multiplied by the total volume, right? So 3 by 8 multiplied by the total volume, which is, we already calculated that, which is 264,000. When you multiply that and you continue with this, you can simplify it, right? And further then multiply it, you will get 99,000 cubic centimeters. Now the question is asking us liters, right? How many extra liters of liquid? The answer that we got is basically in cubic centimeters. So we're going to convert the cubic centimeters into liters. How do we do that? We just divide by 1,000. So 99,000 divided by 1,000 is 99 liters. So that's the answer to the first part of question. Then the question tells us how long will it take to fill the tank completely if the tap fills it up at the rate of 5.5 liters per minute. A very simple question. Only thing that you need to understand here is that rate is equal to liters divided by minutes. Pretty much very similar to the previous question that we did. Rate is equal to liters divided by minutes. Rate is given to you, liters is given to you, you need to find the minutes. In place of rate, just write the rate, which is 5.5. Liters, we just found it, which is 99 divided by meters. Okay, so since meters is down here, I don't want it to be a division in the place of division, so we're going to do first multiply minutes on both sides. If I multiply minute on this side of the equation, they will cancel each other out. If I multiply minutes here, it will come out like this. Is going to be equal to 99. Then I have to divide 5.5 on both sides. Okay, 5.5 here will cancel each other out, and minutes is going to be equal to 99 divided by 5.5, which is going to be equal to 18. So the minutes is equal to 18. In other words, 18 minutes will be needed for the tank to be completely filled. That was it. That's it that you need to do about this question. If you have any questions, then you note them down and you're going to ask me on Monday. Okay, make sure that you remember those points then.